Hello students, this is a review session for exam 2 and this is going to be a long review. We have a lot to cover. By the way, this is the original problem set I used several years ago and it goes like this. We have a problem and then what do you see here? An outline of a normal curve. As a matter of fact, it's a t-curve, but you cannot see the difference between z-curve and t-curve in naked eye. Another subpart, another outline. Even more outline. Each time you do a problem, you have to draw a picture, sometimes two. I hope you see the picture. Some pun intended, obviously. It is very, very, very important you draw the picture. If you don't draw the picture and then somehow get it right, okay, that's great. But then again, there's very low chance. Now, if you don't draw the picture and then your answer is wrong, then you cannot expect any partial credit. Okay, let's begin. The article, Development of Novel Industrial Laminated Planks from Sweet Gum Lumber, Journal of Bridge Engineering, 2008, blah, 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 describes the manufacturing and testing of composite beams designed to add values to low-grade sweet gum lumber. These are the sample statistics. As you see from this source, this is not a made-up numbers. These are actually coming from real-life study. And then let's do some real-life application using elementary statistics. First, let's find out 95% confidence interval of the mean modulus rupture. Okay. This is the mean observed. So we're going to have some plus or minus something, margin of error, find out, and then plus or minus the margin of error. That's called the confidence interval. It depends heavily upon this confidence level. And this is how we begin. First, this is probably the most important step. Draw a picture. Okay, looks like this. By the way, I have to initialize so that I can draw the picture correctly. First, an outline, and then mark the center, and then end here and there, and then shade accordingly. This is the order. Outline, center, end, and shade. Okay, outlined, going up and down, symmetric unimodal, kind of like that. And then the center is the observed mean. And then we have two endpoints, symmetrically here and there, x1 and x2, and that's what we are looking for. Okay, now the strategy is set. Oh, by the way, we are looking for a 95% confidence interval, which means 95% of chance in the center, the green part, and the other 5% will be shared by left and right. So 2.5% in blue and 2.5% in red. Okay, all right. We are done with the most important part, and then let's go with some computation. What's the degree of freedom? n-1, please prepare this in your formula sheet. 30 minus 1, so 29 is the degree of freedom for this case. And it's way less than the typical threshold of 100, so we're going to use the t-curve, not the normal curve. Okay, and then let's go ahead. The most important formula here, end minus center over SE. Maybe I should increase the font. Okay. End, where's the picture? Okay, this is the end you're looking for, x2, and that's the center. So end minus center over standard error, SE. And that should be appropriate t-statistic related to 95% of confidence level and the degree of freedom of 29. Let's go ahead and find it out. Let's open up a t-table, and that's going to be provided, of course. Okay, here's a t-table. And the degree of freedom was 29, so let's go. Maybe I should increase the font a little bit further. Okay, alright, that's better. 29, okay, 29 is here, down here. Sorry. Okay, 29 is over here where my mouse is running on. And then we want 95% of confidence level. It's this one. Okay, I'm having a little bit difficulty highlighting. Okay, I succeeded. 2.045. That's the confidence level. You can find out from this 95% down here, or you can go up the, oh, what did I do? Okay, somehow this table is breaking up. It must have something to do with connection speed of this internet, I think. Do I have to pause recording? I hope I don't have to. Excuse me. Okay, let's go over to this picture here. That part has to be 2.5%. Middle part has to be 95%. So 2.5% here, 2.5% the other way. So we are looking for this column, 0.25. And the degree of freedom, this column over here, where my mouse is running. And the degree of freedom is 29. So we have 2.045. That's another way to look at it. A little bit more general way. But the shortcut is right down there, 95%. In any way, the table gave me 2.045, so that is my t-statistic. 2.045 is my t-value, and you have n minus center over SE. From this equation, you can find out the end value. Not too bad. N minus center over SE, so n minus center of 7,203. Is that really the center actually? Yeah, this one. And then SE is standard deviation over square root of n. That's what we have down there. Solving this equation, it's just an algebra. Let's flip over this denominator to the other side by multiplying it. Okay, here we go. We got the multiplication. And then flip over the subtraction to the other side. Now we have the addition here. And then all you have to do is run this computation with your calculator. Let's take a shortcut. I just ran it, and then this is what I got. 7,405.656 approximately speaking. And that is the right-hand side endpoint here. How about the left-hand side over here? You can use the symmetry. Look at this picture, it's symmetric. So let's use a symmetry. From the center, we added this much. So if we subtract that much, you're going to get the left-hand side. See the difference? Plus becomes minus. That's because of the symmetry. You don't have to go through all this again. Calculate it. Punch your calculator, you get 7,502.56, and that's this blue point here. So we got this blue and red. So much for confidence interval. Let's go to the conclusion. Left-hand side and right-hand side endpoint. Let me show you the final picture. There goes the confidence interval. Oh, by the way. Okay, now the answer is in the same viewing window.